In this video, I'll show you 3 examples on how to find the central angle of the arc length. This is part 2 in the series. The first question reads, find the radius of the circle in which an angle of 2.06 radians intercepts an arc length of 115 centimeters. To do this question effectively, we'll need to use this formula, where that represents the central angle, S represents the arc length, and R represents the radius. So in our case here, they're looking for the radius, so they're looking for R. Let's rewrite our formula, where we have theta is equal to S over R. We are told that the central angle is 2.06 radians, and that is equal to 115 at the top and R at the bottom. To solve for R, we need to multiply both sides by R, and then subsequently divide both sides by 2.06. If you do that, you should end up with R is equal to 115 over 2.06. Using our calculator, 115 divided by 2.06 gives us a radius that is 55.82. R is equal to 55.82 meters. Now, keeping in mind significant figures, we have 3 here and we have 3 here. Therefore, our final answer should also have 3. We need to cut off the 2, and since 2 is less than 5, we'll keep it at 55.8 meters. So this is your final answer. Let's move on to question 2. In question 2, they ask, how many kilometers, the arc length, north of the equator is a town of latitude 43.60 degrees north? We're missing a degree symbol here, so let's add it. Assume that the Earth is a sphere of radius 6,370 kilometers. Now, we cannot use degrees when it comes to the formula pi is equal to S over R, because it's in radians. So we need to convert first 43.60 degrees into radians. And that's not hard to do. I'll do it on the side here. 43.60 degrees times 180 degrees. And at the top, we have pi radians. I'm using the conversion factor. 43.60 times pi divided by 180. That gives us the following. Keep that number in your calculator for now. Do not clear it. So that number, this, will be right here. We are looking for the arc length. Let's set up our equation. 109 over 450 pi. That's your angle. S is what we're looking for. The radius is 6,370. All we have to do now is multiply both sides by 6,370. That cancels out. And you're left with multiplying this number by 6,370 gets us an arc length of 4,847. 4,847.3. And this number has the units kilometers. Now, because this number has 4 significant figures, and 6,370 we assume to be an exact number, so we won't count the amount of significant figures there, our final answer should also have 4. We have to cut off this 3, and our final answer is 4,847 kilometers. Let's move on to the last question. If we assume the Earth's orbit around the Sun to be circular, with a radius of 150 million kilometers, so we'll represent R in scientific notation as 1.50 times 10 to the power of 8 kilometers. How many kilometers the arc length, which we'll represent as S, does the Earth travel around the Sun in 125 days? So this number will relate to our angle. Now, how do we find our angle in radians? Well, we know that in 1 year there are 365 days. So to find the amount of revolutions, we take 125 over 365. Also, 1 rev is equal to 2 pi radians. We can use this conversion ratio to convert this many revolutions to radians. And here's how. 125 over 3 65 rev times 2 pi radians over 1 rev. Multiplying these two numbers out, these units cancel out, giving us 125 times 2 pi divided by 365 gives us 2.15. 2.151 radians. This will represent our angle. Now we can go ahead and use the formula S over R, where we have 2.151 is equal to S over 1.50 times 10 to the power of 8, multiplying both sides by R, both sides by this number, gives us the following. So multiplying that by 1.50 times 10 to the power of 8, we end up with this gigantic number of 322766368. Since we only want 3 significant figures, because of 125 days shown in the question, this gives us 3.23, because the first removed digit, this 7, is greater than a 5, so this will increase the 2 by 1. So we end up with 3.23 times 10 to the power of 8. 1, 2, 3, 4, 5, 6, 7, 8. 3.23 times 10 to the power of 8 kilometers. This right here represents the arc length for this problem. And so there you have it. 3 examples on how to find the central angle of the arc length.